If we will talk about the architecture of data that is stored inside a computer, we have two forms here, or ANSYS POC architecture, like internal architecture and external, or like physical storage and conceptual storage. The physical storage is the way how a hardware or a software operates with the data in binary or textual form. And the concept form or external representation is the form that is understandable for a business process or the stakeholders of this business process. And the data model, requirement of the data model is that the structure of data should be organized in such a way that we understand this data in an external form. And also the database management system should provide a way to apply constraints of the data that can be used for data integrity criteria. The types of data for nowadays are most common used are relational data and hierarchical data or network data, and many of those type of databases and database management system exist till now. And now we have two main categories of this data as relational database and NoSQL. SQL here is the structured query language that envelops all of the relational database management system architecture and all of the other database management system like document-oriented and key-value document-oriented, key-value storage systems, and graph storage system, network storage system, and many other. They exist along with each other to solve different kind of problems. The hierarchical database management system, and one of the examples of hierarchical database management system is operating system file storage system, where we have files and folders, where all of the files that can be stored inside the folders, and folders can be stored inside other folders. And also in this hierarchical database management system, we can have links to files that physically don't exist but address a file that is stored inside of a path of folders and inside of folders. The relational data model typically represented as tables, and tables that have relation to each other, where a table can be perceived as the number of columns and rows, where columns represent the attributes of the entity and row represents the entity itself. The relational model was proposed at first in IBM Corporation in 1970s by a team of Edgar Code, and they have proposed the layer that can help the programmers to operate with data no matter what kind of architecture or storage system they have. And this layer addressed the problem that could arise with data, like data anomalies. And Edgar Code provided 12 rules to create such database management system, and what criteria or what features does a database management system require to become a management system. And those 12 rules are next. The first rule, the informational rule. The informational rule says that everything in database must be stored in table format. And guaranteed access rule. The guaranteed access rule is the second rule that says that each time you address the necessary value or a necessary piece of information, you can address them by knowing a table where it resides, the number of row where it resides, and a number of features that you would like to extract as the interpretation of columns. The systematic treatment of null values. The null values is a very important kind of a value that can be stored inside a database. It doesn't mean that database doesn't have any information. It means that according to this criteria, this specific row does not have an initial value. An active online catalog that provide you the authorization and authority to access or maintain the data. The comprehensive data sub-language rule means that there should exist a consistent way. How do you operate with the data? How do you explain the data? And how do you control the meta information of the data? The typical relational database management system, for instance, can be controlled by strictly usage of structured query language. The view update rule, the high-level insert, update, and delete rule that provide you instruments to efficiently manipulate with data inside the storage system without a consideration of a hardware architecture. The physical independence means the same absolutely, where you operate only with the structured query language and you are not worried about where your data resides, if it can be a local machine, or if it can be a network machine, or if it can be a persistent storage or random access memory. Logical data independence, integrity of independence, distribution independence, and non-subversion rules. Those are the rules that were claimed as the rules for the database management system that should be kept if you would like to create such management system. For nowadays, not all of those rules are followed by different kind of database management system, and the main answer here is that you have to consider task at first. What kind of operations will be the major operations for your business process, and then is it important to maintain consistency within your database? Is it important to store every piece of information? And if it is important, to authorize the access for every piece of information and log every kind of access to this information.